Good morning, grade 10s. This video covers a question on electrostatics. Two identical aluminium spheres, X and Y, are charged and then mounted on insulated stands. The insulated stands prevents the the metal spheres from discharging quickly. And the spheres themselves are made of aluminium, as it is a metal, and the charge will distribute evenly over the surface of the metal. And the spheres are usually identical, so that if there is a chance that they are made to touch, then the total charge will distribute evenly or equally over the spheres. Sphere X has a charge of plus 12 microcoulomb. You need to know that during calculations, the microcoulomb must be changed into scientific notation. So you need to use 10 to the power minus 6 coulombs there. And sphere Y has a charge of negative 4 microcoulombs. So it's negative 4 times 10 to the minus 6 coulombs. A third identical uncharged sphere, Z, also on an insulated stand, is placed to the right of sphere Y, as shown in the diagram below. First question, 5.1. Why is aluminium a suitable material to use? It is because it is a conductor, and charge will spread evenly across the surface. Question 5.2. Name a suitable method that can be used to charge the spheres. Any suitable method. It could be by friction, rubbing the spheres with a cloth, or by contact. When you touch the sphere with an already charged object, then the spheres will get like charges. So if you want to positive 12 microcoulomb charge on X, you would use a positively charged object and a negatively charged object to charge the sphere Y, or by induction. If you want a positive charge on sphere X, you'll use a negatively charged object to charge it positively by induction. And with Y, when you use a positively charged object, hold it above or near sphere Y, touch it, you will cause a negative charge on it. 5.3. Why are the spheres placed on insulating stands? Because that prevents the spheres from being discharged quickly. 5.4. Name a suitable material that can be used to make the insulating stands. That would be wood, plastic, rubber, anything that is a non-conductor. glass as well. You could use glass. Name the force acting between the spheres. Number 5.5. It is an electrostatic force, or a Coulomb force. 5.6, in which direction will sphere Y experience a force? Now, sphere Y is neutral, but it's got charges on it, and the electrons on this metal, in the metal, are free to move around. So the negative charge on sphere Y will cause polarization of the neutral sphere Z. So the electrons that are on this side closest to Y will be pushed to the other side, so that the side closest to Y is polarized positively. And that causes a force of attraction. Let us just write it so that it's slower for you to see. It is to the left. And 5.7, the reason for this, if you want to explain why this happens, the negative charge on Y will cause the polarization of Z by pushing electrons on Z to the right. So the negative charge on Y will cause the polarization of Z by pushing the electrons on Z to the right. And therefore, the side closest to Y is positive, polarized positive. Overall, Z will remain neutral. And unlike charges, will attract. Right, so Z will be pulled towards Y. All right, that brings us to the end of question 5.7. Let's clear all this. To move on. Spheres X and Y are now made to touch for some time, as shown in the diagram below, and then placed in their original positions. So they ask us to state the law of conservation of charge. The law of conservation of charge says that the total charge on an isolated system will remain constant. Means that no discharge of the system will take place. 5.9, we have to calculate the charge in Coulomb on each sphere after contact. So the charge, because these spheres are identical, the charge on X will be equal to the charge on Y, which will equal the total charge divided by 2. It will split in half. So the total charge is calculated by taking the plus 12 microcoulomb and the minus 4 microcoulomb and dividing it by 2. Because the question asked you to calculate the charge in coulomb, you can't leave your answer as a microcoulomb. So this becomes 8 microcoulomb divided by 2, which gives us plus 4 microcoulomb. Come on. $5.10, so that was 5.9. 5.10, they ask us to calculate the number of electrons transferred between the two spheres during contact. 5.10 says number of electrons. Now, the number of electrons would be the charge that was transferred, and I say it will be the charge, the change in charge of one of the spheres. I'm going to use sphere X divided by the charge on an electron. Now, X started off having a charge of 12 microcoulomb and ended off having a charge of 4 microcoulomb. So the change in charge would be the final charge 4 microcoulombs minus 12 microcoulombs divided by the charge on an electron, which is negative 1.6 times 10 to the negative 19 coulombs. So this brings us to minus 8 times 10 to the negative 6. That's the difference between the final and the initial charge on X, divided by minus 1.6 times 10 to the minus 19. Your answer should always have a positive value, and the exponent of the 10 must also be positive, because you can't have parts of electrons or fractions of electrons. So let's do this calculation quickly. Divide that by 1.6 minus 19, and I get the number of electrons transferred, 5 times 10 to the power 30. Right. Thank you. I'll see you on the other side of the next video.